together with colleagues today, we're going to get you started writing stack questions. So I'm not quite sure who everyone is. I know we've got a group of folk from Edinburgh. Thank you for joining us today and welcome. Thanks for your interest in this. We've also got some colleagues from around the world. I don't know quite what everyone's level of experience and competence is. So we're going to take it very slowly and we will have plenty of time to follow this up after the session. I will say a couple of things about stack. The first one is it's complicated, right? I mean, we're trying to automate the process of assessing students' answers and giving feedback to that, okay? It's a complicated beast. So the goal for today is to get you to write one question successfully. Now, some of you will not be writing stack questions from scratch. I know the Edinburgh folk will be reviewing and editing things. So we just want you to know enough. For those folk, we just want you to know enough to be able to edit things successfully and fix minor mistakes. For other folk, you're going to be writing a whole bunch of materials. You'll be asking about all sorts of features. You'll be wanting to know what this does and what that does. So we'll try and cater for all those people. I'm going to start by just sharing my screen and explaining what we're going to be doing today. So let me share my screen. Okay, so this is the plan for today. I'm going to introduce stack. We'll then get you started with authoring, and Malthe will take you through that. We've then got half an hour for group work and writing questions, and I'm sure we'll have a 5-minute break between these two things to make a cup of tea or whatever. And then we'll have a question and answer discussion. I think in round numbers, when I've taught people who really want to know everything about stack and be completely independent, takes anywhere between 2 weeks and a month, right? Is that about right, folks? George, is that about right? Constantina?
That's how long is a piece of string, really, isn't it?
Yeah. So you know, don't expect that you're going to know everything straight away, right? Just be prepared for that, please, because that's what it takes. So what I want to do in my introduction is to show you what stack is and just explain some basic principles of the session. So I'm going to take you, if I remember to share my screen again. Oh yeah, this is being recorded, this session, just so you can come back to it later. So if you miss something, we are recording this session. So I'm going to go back to the demonstration site, not that one, but the right one. So I'm on this server, we're in demonstrating. If we go into demonstration here and demonstrating stack, this is the demonstration site with some materials on it. And just to say for those folk who are not in Edinburgh and who are thinking about this, all these materials are distributed with the source code. So if after this session you want to see how did he get that question to do this, you can install all these questions on your own machine and you can edit them to your heart's content, okay? So this is all distributed with stack. And I'm going to go into the demonstration quiz and continue the last attempt. We'll go back to question 1. Okay, so this is a kind of typical stack question. It's a completely dull, calculus question. But it shows the idea behind stack. So the idea behind stack is that the student should type in a mathematical answer. So if this was live, I'd ask someone to get it wrong, but I'm not live. Well, I mean, I'm not in person, so I won't do that. Okay, there we go. So the principle is that the student provides a mathematical answer. And there's the mathematical answer. It's a mathematical expression. And you've already seen it's got to be syntactically valid. So one of the key design features of stack is this separation of validity from correctness. That is a key design principle. So that the student should get a valid mathematical expression before we decide if it's correct. And there are a whole bunch of reasons for wanting that, okay? One, nobody likes being penalised on a technicality, and we work really hard to make sure that students are not penalised on a technicality. So if you should type in an equation and you just type in the right-hand side, that could be invalid if the teacher decides it's invalid, right? The second reason for expecting a valid expression is it makes the marking algorithm robust. So if as a teacher you're expecting an equation, you can't ask for the right-hand side of something that's not an equation. It will throw an error. The software will throw an error. Of course it will, because it doesn't have a right-hand side. You just type in a polynomial and you're expecting y equals something, right? It doesn't have a right-hand side. So by knowing in advance that you've got an equation, your marking algorithm will just be so much more reliable, right? Now, it's up to the teacher, has some options about what will and won't be valid and what will and won't be correct. So there is some choices to be made about what you want from a student's answer in a particular situation. So if I go back to sharing my screen again, okay, so here, I mean, this is just always going to be wrong, isn't it? There's a missing bracket, okay? That's never going to be correct. But what about something like that, right? I mean, your answer contains floating point numbers that are not allowed here. You need to type in numbers as fractions. For example, 1/3 should be not 0.33, okay? So, you know, if a student types in 0.33, that is 33/100ths. That's what it means. It means exactly that and nothing else. It's 33/100ths. It's not a third. So if you are in pure maths and you want exact answers and you want to establish the equivalence exactly, by rejecting that as invalid and not wrong, you can tell a student to type something in. It's 99% certain if a student types in 0.33, they know it's a third really, right? I mean, we know that you know what they're doing. So why would you penalise them on a technicality? Okay, so this separation of validity from correctness is a key decision. Okay, right? So let's do something like this. So we've got a valid expression. In this context, we've made all our choices, that's valid, and then the student will check it. So here's the correctness. The derivative of your answer should be equal to the expression you're asked to integrate, blah, 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 blah. In fact, the derivative of your answer with respect to x is this, so you must have done something wrong. So what we've done is we've taken, share my screen, thank you, George. Just being inept on a Monday morning. Okay, so let's run through that again. I've typed in a valid expression, I press check, and the system has decided what it wants to do. The derivative of your answer should be equal to the expression you're asked to integrate, that was blah. In fact, the derivative of your answer with respect to x. Okay, so the system is automatically taking the student's answer, it's manipulating it, and it is establishing mathematical properties. So now the second trick in this game, as a teacher, you have to decide what are the relevant mathematical properties that make this answer correct or incorrect. Okay, that's the first task. Right? So what are the mathematical properties in this? One, it should be a symbolic antiderivative. Right? Secondly, it should have a constant of integration. And then maybe it should be in the right form. Okay, so in this question, there are at least two things that make it correct, and one may or may not make it, fully correct. That's an aesthetic judgment. If we go back to this question, I would be a little bit disappointed if a student expanded out that polynomial and integrated it term by term, right? So you might look for the factored form for evidence of the way the student has answered the question, right? But now, it wouldn't be completely wrong if a student expanded that out. And if we really didn't want to expand them out, we would have put 600 and not 6, right? I mean, that's fair enough, okay? Does that make sense? Yeah, right. So how do we establish these properties? Well, on the server is this software called Maxima, okay? And there is a desktop version. So if we have, what was this polynomial? X minus 4 to the 5, okay. So in the background, we have this polynomial x minus 4 to the power 5. And we have answer 1, what was it? It was x minus 4 to the power 6, okay. So what we need to do is we need to write some code that will establish that this is a correct answer to that integral problem. So I could integrate p with respect to x, and Maxima's expanded that out. I don't know why on earth Maxima's done that, so we might then factor that. As you can see, this software, for those not used to computer algebra, this software, right, oh well. Anyone realize why it's done that? Not maybe what you expect. There's a good principle here. Anyway, we're not going to integrate this. What we're going to do is we're going to differentiate the student's expression. Okay, and we're going to compare it to the question. Because if the student has added a constant of integration, by differentiating the student's expression, right, we don't need to see the constant of integration to establish whether this was an antiderivative of that. So sometimes the way in which you actually establish the properties that you're interested in is a little bit indirect, right? Okay, and that says, so there's an art to how you might write the algorithm that establishes the properties. How do you establish a constant of integration? Does it matter whether the student has used a plus C or a plus K? Well, let's have a look. Let me get this right. Okay, so let's improve my answer, have another go at this question. You need to add a constant integration, otherwise that appears to be correct. So now add a constant integration. My view on this for the students is they should get no marks if they don't read the feedback. That's tough, right? If you can't, as a student, if you can't be bothered to read the feedback and act on it, you're not getting any marks. Now, that's my decision as a teacher. Some of you might be balking at that decision and saying, oh, that's completely ridiculous. Of course, in an exam, that would be a completely ridiculous attitude to take, wouldn't it, right? But in a formative setting, I want you to read the bloody feedback and act on it, right? That's what I want you to do. Now, we can argue about marks all day, but as a teacher, you are responsible for what happens in your own classroom, okay? So you have to make all these decisions about what is correct, what's not correct, how many marks to give, what feedback might be helpful to the students, and all the rest of it. There's a bewildering array of choices, and we're trying to automate this process, which is why Stack is complicated. Okay? Right, so does it matter which constant of integration I use? C is fine, so let's check that. I've added my plus C, great. K, okay, C squared maybe. Right, the formal derivative of your answer does equal the expression you're asked to integrate. However, you have a strange constant of integration. Please ask your teacher about it. So what does it mean to have a constant of integration? Right. Maybe you'd like to, after this session, because I'm running out of time, but after this session, you might like to go away and think, what does it mean to have a constant of integration? And how would you establish that? Yeah? I have to say, writing Stack questions has forced me to think about a lot of issues in elementary maths I would never have thought about deeply if you're not trying to automatically establish something. And writing code to mark students' work is a really demanding high bar on your understanding of the maths, actually, trying to automate that process. I think if you can write some code that marks someone else's work automatically, you've probably got a very good understanding of the maths. Okay. Right, so let's go back to this question. So what kind of feedback does this do? If we click on this link here, question, tests, and deployed variants, it will allow me to just show you a couple of other features behind the scenes. So Stack randomly generates problems. And then these are test cases. So if this, behind the scenes, we are creating, if I scroll down to the bottom here, we are creating random variables. So these are the values of the variables. N is 5. A is 4, V is X, the variable, and now we've got the problem and we've got the teacher's answer, okay? So the system is randomly creating random variables, and you can see here that there are all these random versions. Now, in the background, Stack mostly doesn't create random versions on the fly. What you do is you pre-generate random versions, and the student gets a selection from that list, and that allows you to make sure that every random version works, right? You know, I say randomly generate a straight line, randomly generate a quadratic, and say, where does the straight line meet the parabola? You know, for sure, I'm going to randomly generate some that only meet in the complex plane, okay? And that's going to be deeply confusing if you've never met complex numbers, and not at all what I wanted, okay? Or you randomly generate one version that's just trivial or impossible or whatever. So by randomly generating and pre-generating, we can quality control our materials, because that's what we want. We want high quality stuff, okay? So in the background, we randomly generate this and then we test them all. So if the student types in the variable TA plus C, well, that in this case is this random version. And sure enough, it scores 1, we expect 1. Here is some notes for statistical purposes, and this test passed because we got the score, we expected the score. Let's say the student just enters this expression, which has not got a constant integration. You can check that that feedback is being provided. Let's imagine you've done something completely random. It looks like you've differentiated instead. That feedback is being given. So you can check all these cases. This one, here's one that's invalid, look, right? We're checking that it's invalid. We're checking that that's being rejected. So when you're writing questions, it's really important to test those questions. We can make sure that every random version is tested correctly. And from year to year, right? I mean, I've been doing this for 15 years. We keep upgrading the server. We keep changing the features. I want to make sure that next year, the questions haven't changed. They still work, right? So from year to year, this allows us to, before the year starts, we run every test on every random version of every question, and it throws up a whole long list of this has changed and you need to just fix this question for this year. Okay? Right? So that's what Stack does, and the rest is just, of course, a catalogue of features. Right? So I'm going to hand over to Malthe, who's going to take you through how you write your own question.
Thank you, Chris. Thanks for that introduction. All right. Good morning, everyone. So my name is Malthe Sporring. I'm from the University of Edinburgh, and I'm a fairly new addition to the Stack team, so to say. I was a summer intern last year, and one of the things I did at the internship was I improved how people learn Stack. So if any of you have seen the Stack tutorial video series, you might recognize my voice there. And it's that experience I'm going to try to draw on today, because I'm going to be teaching you all how to write your first Stack question. And now, most of you have registered for the course, and I can see that for the most case, the people in this call haven't written a Stack question before. There are a couple of you that have written a few, but most of you have never written one before. So that's really the big goal for today. Okay, I'm just going to share my screen. So you should all have access to this course, Getting Started with Stack. And this is where all the material for the workshop will be. In particular, we have a authoring Q&A section. So please, if you have any questions along the way, if you could please put them in here rather than just in the chat in Zoom. If you put them in here, it means they're preserved for afterwards. If you want to come back and read at some of those answers, that'd be really great. And the other thing we have is we have a question authoring area, right? So if you click on this link and use the enrollment key Stack 2020, this is a course we've set up for writing questions. So once you sign up, you will be set up as a teacher on this authoring course. And what that means is that you have access to the administration pane, and in particular, you have access to the question bank, right? And this is where you write questions, you edit questions, you do all that sort of stuff, okay? So please make sure that you can sign up as a teacher here. And you'll see there are instructions for how to write questions. So you have to go to question bank, create a new question, pick the question type, and then type away. Okay, that'll be in a moment. But first, I just want to say a couple of disclaimers, right? The first thing is Moodle, which is what we use, which is the learning environment we use. It's not made for several people working on the same question at once, right? Like something like Google Docs is. You can't do that in Moodle. It's really meant for one person to sit down and edit the question at once. And what happens if you try to have two people edit the same question is that it might break, okay? So if later on you're editing your question and you notice something strange, there's a good chance that it's because one of your colleagues is editing the question, okay? One of the things we can do to stop that happening is to make sure we name our questions very personally. So I strongly recommend that you put your own name in the question name and only edit the questions with your own name in it, I guess. The other thing is that we reuse this kind of authoring course for a lot of our workshops. So it means that once every month or so, we wipe it clean and we remove all the questions that are there, because otherwise it just gets bloated up with years and years of small little test questions. So if you want to keep your questions after today, please export them onto your own computer. And also, please don't use this course area to write any important questions that you're going to use at your institution, okay? If you need an area to try writing out questions for your institution, please get in touch and we'll see what we can do. For the undergraduate, the University of Edinburgh undergraduate students here, you won't need that. We already have an area set up for you to work on. But for anyone else, do get in touch, right? Okay, so One other thing you'll see here in this authoring course is that we have links to the documentation. Okay, so let's have a look at that. Right, so this is the Stack documentation. You can see that we've split it into sections. So there's sections on about Stack as a project. There's something information for students, but what's most important for you is all the sections on authoring. So on all sorts of authoring topics, and we've picked some of the most important ones, some of the most common ones out here. But if you scroll all the way to the top and you click on the sitemap, you can see all the files that are part of the documentation. Particularly, these are all the authoring files. These are all the files related to CAS, which is the computer algebra system. So there's really a lot of information to read here. And the reason is that, well, Stack is 15 years old at this point. And every time a new feature is added, it's documented in the documentation, okay? So if you have any questions about Stack, what I'd really like you to do is first check the documentation, right? There's about 15 years worth of answered questions in here. So, chances are your question will already be answered somewhere in here. And actually, what I said earlier that I wanted to teach you how to write Stack questions, that's maybe not entirely true. I really want to teach you how to use the documentation, right? It's like the saying goes, give a man a fish and you feed him for a day, right? But teach a man to fish, you feed him for a year. I want to teach you how to teach yourself to use Stack. Okay, but we are going to start out with me showing you how to write a simple question, okay? And what we're going to be following today is this series of authoring quick start guides. There's about 8 of them, and they're made to give you the most essential information for Stack, which will probably keep you going for most of the problems you'll have, right? It'll really help you write some quite good questions to get started with. And we're going to start out just with this first question, just in a moment. Before we do that, I just want to have a quick note about editors. So Moodle has its own editor it uses, right? And it's quite a nice editor. So you can add tables, you can add images, et cetera, but it does have some problems. One of the things it does is if you copy and paste like a JavaScript plugin or maybe some HTML code, sometimes it will interpret it wrongly, right? It tries to turn it into something it can show you, but sometimes that just means that what you're copying in breaks, okay? And especially for you undergraduate students that are editing someone else's questions, that can be a really big problem, right? You go in, you've got your Moodle editor, you're just editing a typo, and once you save, suddenly the question's broke. So really what I'd recommend you all do is you go up here to your profile, you click on Preferences, and then under User Account, you click on Editor Preferences, right? And then by default, you'll have the default editor, but I strongly recommend you pick the plain text area instead. What this means is what you'll be typing in is just raw HTML code, if any of you know how to write HTML. And it really means that nothing can break, right? Because it's just raw input it's getting. So I strongly recommend you do that. Okay. And the other thing I'll say before we get started is that Stack has no undo, right? This is another problem when we're working on questions together. If you make an edit and you save, you can't go back, right? It's saved. That's what the question is now. So really be quite careful with that. And sometimes what I do if I'm trying something out, if I'm taking a question, I'm trying to find a fix for it, I'll make a duplicate of it, make all my edits, and then once I've saved it and I'm happy with it, I'll copy it over to the original question, right? That can be quite helpful sometimes. Okay, Now, before I get started with the authoring quick start guide, I just want to see if there are any questions at this point, just about finding your way. So if anyone can't find what I've been talking about so far, please speak up now. No, great. Okay, good to hear. Well, in that case, I'm going to go to this authoring quick start guide, right? For just getting a minimal working question, okay? And you can either get it in video form, we're just gonna look at text form. Okay, so the first thing it says is how to get to the stack question. So we should go to the course, we should navigate to the question bank, we should create a new question with the stack question type. Okay, right, so let's go to the authoring area. We'll scroll down and the question bank is down here, right? It's a little bit hidden, but it's under administration, course administration, question bank, right? And here we can see all the questions. You can see we've used this before for other workshops. There are plenty of questions already. But what we want to do is we want to create a new question. And then you have to pick what type of question you want to add. So there are a bunch of options that Moodle provide, right? Simple, multiple choice, true or false, etc., etc. But if you scroll all the way to almost the bottom, we have the stack question type, which is what we want to be picking today. So we click add. Right. And here we have the stack interface, okay? So just as a quick overview, right? You've got the question name. You've got something called question variables, which is where we'll be doing a little bit of coding, I suppose, later on, but it's not necessary. What is necessary is the question text, and this is the actual text that the student sees, right? You've got some options for providing feedback, and then there's a section for options on the input, right? So you can pick what type of input you want. For example, you want it to be a number, or you want it to be true or false, right? But the default algebraic input works most cases. It lets a student put in a mathematical expression, right? And then we've got the model answer, which is the quote unquote correct answer, right? And the quote unquote is because in stack you can have a question with many correct answers, right? That's one of the reasons why we want to use stack, is we're not limited to just one correct answer, right? A correct answer could be, you know, any answers that's factorized, or any answer that integrates to a certain expression. But you do need to give your teacher's model answer, even if you're not actually using it in the question, right? This is just part of the stack interface, is that you need to give a model answer. Okay, and you have a lot of options for the input type, which I won't go into, but I'll show you the potential response tree, right? And this is where we do the grading of the student's answer, okay? So we create these kinds of trees which can have as many nodes as you want. And at each node, you pick an answer test, which will test some kind of mathematical property of your answer, or between the student's answer and the teacher's answer. And you can have as many nodes as you want. So you can have one node that checks if it's algebraically equivalent. You can have a node that checks if it's factorized. And you can really go quite crazy with it if you want. But we'll look at that a little bit later. However, this is the other thing that's required for a working question, okay? And then there's some extra options. All right. I see there are some questions in the chat, so I'm just gonna have a look. How do I get to the chat? That's not what I wanted. Right, that's right. So Chris is just saying that what the model answer is oh no, I accidentally went out. but when the question is shown to the student, you can choose to show the model answer after they've entered their answer. So it's an example of a right. You show to the student what's the correct answer after they've entered their answer. Okay, that's just what it is. Right. Okay. So let's go back to the quick start. Right, so we talked about the things that are compulsory. You need a name, you need question text shown to the student, you need a model answer, and you need to create a potential response tree which marks the student's answer. Okay, so it recommends we give the question a name. Let's just go ahead and copy that in. Right, question 1. Now, as with the thing I said before, let's try not to all name our questions the same thing, because we're going to accidentally end up editing the same question. So I'm going to add in my initials, question 1. Okay, so please do that as well. If you're following along, please do that. Okay, and then you need to add in some question text. So we're focusing on the problem of differentiating x minus 1 to the power of 3 with respect to x. We need to write the question text itself. Okay, so let's just copy in this into the question text. Right, okay. So a few things to notice about this is that we've got these strange slash parentheses around here. And what these do is these actually display latex. So you could display latex in the question text, which is really useful, but you can't use dollars. Instead, you have to use slash parentheses around inline math you want to show, and slash square brackets around display math you want to show. Okay. So that's just how we do latex in Stack. However, I will say if you've got a lot of latex you want to copy over, maybe you've got some bank of materials you want to turn into questions, there is an option at the bottom to automatically replace single dollars with the correct delimiters. Okay, so you don't have to do all of this tedious work if you're doing a lot of copying over. All right, and the other thing to notice is that we've got these two areas. One of them is called input, and the other one's called validation. Right, so this just puts an input box for the student to put their answer in, and saves it as the variable called ans1. And then it creates another box that's the validation, which is the white box that Chris showed you when he previewed one of the Stack questions, which just shows how the answer is interpreted by Stack. Okay, you can put these anywhere in the question you want, right? They don't have to be next to each other. You could have the input box up here. You know, sometimes you want them in different places, right? And you can have as many of them as you want. So you could have several input boxes if you want to have a multiple part question. Just make sure that you then give them different variables for the different answers. Okay. All right. Let's see what's next. Right. So there'll be an input section, and we must specify a model answer. And this has been given here. Okay, so let's scroll down. We've got the input section for the input that we've called ans1, right? The input type is it's an algebraic expression, and our model answer will just copy this in as 3 times x minus 1 to the power of 2. Now, one of the things we get asked about is, or that there's some confusion about, is what syntax to use in each of these boxes, right? So I set up here, this one is kind of latex syntax. And this one is Maxima syntax. So in particular, what it means is you have to use stars for multiplication, right? You have to really explicitly say what operators you're using. And how do you know which of the input boxes use what? Well, one of the ways to know is just to click on the little question mark by the input box, right? This one will say, this is cast text. Okay, so this is normal text. You can use latex delimiters, right? But the rule of thumb I'll give you is if it's a box that shows a lot of text for the student to see, it's probably cast text, right? It's probably something that uses latex syntax. However, if it's more behind the scenes coding, it's probably this Maximus syntax, okay? Right, let's see what's next. Right, we said the model answer has to be a syntactically valid expression in Maxima, which is the computer algebra system we use. Okay, and we can have a variety of types selected in the input type, and we've chosen the algebraic input. Right. Okay. The final thing is that we need to assess correctness of our response using the potential response tree. Okay. So by default, we have one potential response tree, but you could have several. You can create more, okay? And it's put in this tag called feedback, feedback PRT1, which is the name of the tree, right? In a similar way to how we gave names to the input. And by default, we put it in the specific feedback box. And for most questions, you could just leave this empty, and this little feedback block will be replaced by the feedback that we're going to be giving later. But if you're writing a multiple part question, sometimes you want to move this block up actually in the question text, okay? But for most purposes, it's fine to just leave it right here, right? So let's scroll down. And here's our potential response tree called PRT1. Okay. And we've just got a single node called node 1. And let's see what they want us to do. Okay, so at each node, S ants, so the student's answer, is compared to T ants, which is the teacher answer, with the answer test, possibly with an option. If true, we execute the true branch. If false, we execute the false branch, right? So this is the part where we're testing. The green block is the true branch, and the red block is the false branch. So each branch can update the score or the mark, assign feedback, leave an answer node, or continue to the next node. Okay? So let's just configure this correctly. So we should select ans1, which, as you may remember, was the variable we gave to the student's answer as ants. And for the teacher's answer, we should put in what we had as our model answer. Right, so let's do that. S ants, we have ans1. T ants, we have 3 times x minus 1 to the power of 2. And our answer test is algequib, which stands for algebraic equivalence. It just checks that the student's answer and the teacher's answer are algebraically equivalent. It doesn't check for how the form is, right? So if their answer is expanded, but is essentially the same expression, it comes out true, right? Okay, and then I think we should make sure that when it's true, we set score equal to 1. And when it's false, we set score equal to 0. Okay? So that's how you change the score. And then we can give some extra feedback if you want. So when they get it right, we can get well done. And when they get it false, can get, please try again. Okay? And out here, the answer notes, they're generated automatically. And these are just used for reporting purposes. So later on, when you want to kind of review your potential response tree, you might want to refer to each of these each of these particular parts of the tree. And you can see this one, it's just saying we're on potential response tree 1, we're in node 1, and we're in branch true. But you can, if you want to, you can change the answer node to something else. It's entirely for you as a teacher to help review your potential response tree, okay? Now we could add extra nodes, and then we could send the node on to more nodes, but for now, let's just keep the simple node that just checks their answer is correct, and just stop after that, okay? Right, what should we do then? Now we scroll to the bottom, we press Save Changes and Continue Editing, and then we can preview it. Right, so we scroll way to the bottom, and here we have Save Changes and Continue Editing. Now, if there were any errors in your question, it would not save. And most likely you would get a red error text, either up here or sometimes in the individual parts of the question, and you would not be able to preview it, okay? So in that case, you would have to go back, fix whatever error was stopping you, and then you could preview it, okay? But if you're not seeing a preview block after you've saved, that's probably why. Okay, and then I should make sure to share my entire screen as I click preview. Right. Is that showing all right?
Yep.
Right, I'll take that as a yes. So we can see this was the question text we gave. Here was the input block. And if we put in our answer, we can see this is the validation block. And once we click check, we get to see the feedback block. So in this case, we get a little tick, which says it's correct answer. And then we get this, this specific feedback, which we specified here, right? Because we passed the test, we came node 1 true feedback, we got well done. If we tried doing something that was wrong, we will get feedback for the wrong answer, right? Okay, so that's really all you need to get a simple question working. Right, are there any questions at this point? There should be just stop sharing. There should be a raise your hand feature if you want to raise your hand and ask a question before I move on. So I think if you go to the left pane on Zoom under participants, there should be a dot, which you could click on and raise your hands if you have any questions at this point. Right, I don't see any questions. So in that case, I think we should just charge on with the next part. So we'll just look at authoring Quick Start 2 because I think that one's quite valuable as well. So this one's talking about question variables. Okay, and this is where we really get to start seeing the value in using maxima, in using a computer algebra system to run our questions. Okay, because what we can do is we can specify question variables to use later in the question. Okay, and the way you do that, if I just go back to my stack question, you scroll to the way top, right, under question variables. Okay, and this, because it's kind of behind the scenes coding, we use a rule of thumb, it's not going to be LaTeX, it's going to be maxima syntax. Okay, but here we can define any variables that we want to use later in the question. Now, maxima syntax is a little strange sometimes. So if you want to define a variable, you have to write the variable name and then use colon to assign to it, you know, a number or an expression or whatever. The reason why it's colon instead of equals is because you can also have an equation. assigned to a variable. Okay, so that's the reason why we use colon. What could be really useful is if we had this expression as a question variable, because we've repeated it, or we might want to repeat it in the question text, in the feedback, etc., etc. So let's just define, I might say, expression, and I'll colon to define it, and I'll say x minus 1 to the power 3. Do a semicolon at the end of the line. That's not necessary, but it's good coding syntax. And now we've got a variable that defines the expression. Okay. So if I want to save myself or save myself work, and instead of typing out the entire thing in writing, I just want to refer to this variable we've defined it before. The way you do that is you create curly brackets at and at curly brackets around any maxima syntax you want to use, okay? For example, if you want to include this variable, you have to put curly brackets at around it, and then you can write expression, okay? And maybe let's just confirm, if we save changes, that that is indeed displaying correctly. Right, so it's still displaying it in proper LaTeX, but we've saved ourselves the work of copying this this expression multiple times in our question. So it's really quite useful, and it becomes mandatory if you want to. Well, first of all, if you want to use randomization. So if you want to randomize questions, then you can't just type it out in text because it'll be different each time. So you have to use maxima variables or question variables to do the randomization. And the other thing you can do is you can utilize maxima to create great questions. Okay, so sometimes you want a question that's got a nice simple answer, right? Maybe your answer should be whatever, a matrix with integers, and you want to have lots of random ones of these, but when you just randomly create matrices, you might just get, you know, some that don't look very well, right? You might get some ugly matrices, but you can use maxima to kind of work backwards from a nice solution to what the question is for that nice solution. Okay, so it's really worthwhile to use these question variables. Okay, so you know, if we had more time to spend on this, I might also, well, I'll just do it now. I might specify the teacher's answer, right? And similarly, we can refer to this question variable when we do our model answer. Instead of typing it all out, I can just have it as TA, right? And we can also refer to it in the potential response tree. So we can just check ans1 against TA, right? It's really quite worthwhile. Okay, so I hope that explains question variables well enough. Maybe the last thing that's really quite useful that I'll explain is this general feedback block. And what this is meant to be a full work solution, right? The students really appreciate when you show a fully worked solution by the teacher. So right, well. Yeah, sure. Let's write out a general feedback. So whatever, we use the rule a times x to the power of n prime equals n times a x to the power of n minus 1, right? Okay, that's a very simple general feedback, but I just want to show you how that looks like once we save. in preview, the idea is that once the students have, well, you can choose when to show the general feedback, but maybe one of the more popular ones is to say once they've completed an entire quiz and they've submitted all the answers, so they can't edit it anymore. Right, here we go. We use the rule blah 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 blah. Okay, I maybe did some latex mismatching, but the idea is that then they get to see a fully worked solution at the end of the question. So this is really worthwhile to add in. Okay. Probably what I should have done is instead of using brackets, I should have used curly brackets. I think that's what latex prefers. Okay. Right. So I think I'll stop there for writing a simple question, but in a moment's time, you'll all get a chance to go into groups and to try this out for yourself, right? See if you can actually figure this out. So before we do that, are there any questions at this point?
Malthe, thanks very much. Can I just come in here for the Edinburgh folk? So
Yes, please.
Are you going to be working for us this summer in helping us to generate really high quality questions for our incoming students and our existing students? And we've just seen there where Malthe has, the LaTeX didn't display perfectly. So one of the things that we might be asking you to do is to work through materials and to read the feedback and read the work solutions. And for sure, you're going to spot mistakes like that and other more serious problems. And so what we would like you to do is to be able to fix those kinds of things straight away, right? Without having to raise a ticket and email me and all the rest of it, right? If there are obvious LaTeX mistakes like that, we just want you to know enough about Stack to fix those problems. Or to suggest, oh, maybe add this feedback, or this random version looks a bit difficult, can we get rid of it? Or, this one is impossible, we definitely need to get rid of it. We're not trying to make you complete experts in Stack, but we want you to know enough to be able to do those things yourself without spending hours and hours on it. Does that make sense? As to what we'd really like from the Edinburgh folk. Sorry, that's a very Edinburgh specific comment, but that was a good opportunity. We just want to empower you to fix things without having to, because I tell you, by the time you've emailed me and said, oh, this question's broken, and I say which question and then where and what, you could have just fixed it. Thanks.
Right, brilliant, thank you. Well, what I think we should do in that case is just take a 5 minutes break to go get a cup of tea and meet back at 11, and I'll tell you about how we're gonna do the group work question writing afterwards. Okay, so thank you all, and we'll see you back at 11 UK time. Right, thanks for that, everyone. I hope that was educational, for sure. We have just over 10 minutes at the end of this session for a bit of discussion and a bit of Q&A. I'd love to just go by each group and just hear what all of you did, because I can hear that some of you have been trying out some different things. So I hope you can remember your breakout room names or numbers. Group 1, how did you get on?
That was Chris's group, I think, wasn't it?
Yeah, I wasn't sure who was going to speak. We didn't arrange that. We started with the example question from the authoring quick start thing, with the differentiation, like simple differentiation. And we ended up asking Chris how to do the different potential response tree nodes that we saw in the first example. So if the question is incorrect, looking at typical things the student might have done. So we checked to see if they inputted Y instead of X, used the wrong variables, checked to see if they were integrated rather than differentiated, and lots of different things. And then Chris also talked a bit more about deploying test cases. So yeah, if you go into the deploying random variance, we looked at test cases, but we didn't get onto randomization, but that was useful.
Brilliant. I'm glad. You guys got lucky. You got the main developer doing a little private session. Group 2, how did you get on? Anyone from group 2?
We tried writing the question, an integration question, and sort of going through how to have random variables in the question, and we checked like different ways to like have like the answers with the nodes and all that, and how to give different feedback. And
Brilliant.
pretty much.
Good. Right. You guys got quite far then. Good to hear. Group 3, I think that was us. Does someone from my group want to give a little overview?
Sure. So we did a differentiation question, and we added a second answer, a node. So if you gave the negative of the correct answer, it would display a separate error message. And then we moved on to randomization, where we randomized the coefficients, and just added a test case at the end where we could test if the correct answer was shown if you typed in the right thing.
Brilliant. Yeah. Thank you. Group 4.
We used random variables. We played a bit around with the node tree, and we also, well, in the nodes, we tried to switch between like algebraic equivalence, I think it was, to differentiation to see if we could, like if the question could work itself out instead of having to give it the right answer, but we couldn't really figure out what was going on there. It wasn't working. And then we also made a test case, and yeah.
Right. So maybe for future reference, a really good place to go when you're talking about answer tests. I don't know if you had time to get here, but in the documentation, go to the sitemap. There is an entire. Did you see this? There's an entire article on answer tests. Okay, so next time you find one you're not quite sure what it works or how it works, it's almost definitely mentioned in answer tests. And I bet, I'm going to scroll a little bit fast here, but I bet there is, did you say integration or differentiation? Differentiation, right?
Differentiation, yeah, sorry.
Yeah, right, okay, so the second answer is a model answer, so it's probably this one. You have to use an option for this one. It has to be the variable.
Yeah, we put in an X.
Put in an X. Okay, I'm not entirely sure why then. But for general reference, if you're not sure why an answer test works, go look at the documentation. Anyway, maybe we can work that out later. What was going on? There must have been a group 5. Group 5, how did you get on?
No, I think it was just there were 4.
Just 4? All right.
Skipping.
Brilliant. Okay. Well, in that case, we've got a couple of minutes left for general Q&A. So if you've got any questions, you can either raise your hand. So again, on the left below all the participant lists, there should be a ... for you to raise your hand. Or if you want to type it out, can you please type it out under the course, under the authoring Q&A, just so we keep the questions for future reference. Okay? One of those two. All right, opening the floor to you guys. Scott, go ahead.
Hi there. I was just curious. So if a student got a question wrong, is the teacher able to see the number of responses of the feedback, like the percentage of people which got this partial question right, or the percentage of students? Are they able to see like quite a a well-rounded like stats of like each of the question, and that's what I'm wondering.
Right, Chris, are you happy to answer all of these? I think you're a bit more knowledgeable on the nitty-gritty.
Yeah, I can. So shall I just show you what? I'll just show you. If we go to, if I remember to share my screen, right. So if we go back to this is the courses, demonstrating stack. So let's go into the demonstration quiz. There are 39 attempts, right? Now these are colleagues looking at the system, so I'm sure they're not your contemporary students on ILA, for example, right? I'm not showing you real student data. I'm sure Martin Jones from wherever, or Tim's from Edinburgh, right? So Tim's a colleague. Tim's a colleague in the maths department. He won't mind me showing you his response. So you get a grade book. I can review Tim's attempt. It'll just take a couple of seconds to load this up. So what this will do is it will show me. So this was Tim's attempt. Yeah. Oh, did he get that wrong first time? So it's telling me the time, what he did. It's giving me, oh, he got that wrong first time. Oh, that's a bit embarrassing. So this is the random version. There's only one part to this question, answer 1. That's what he typed in. It was valid, and so it was scored. And this is what the potential response tree did. The mark was 1, and, oh, sorry, this is the wrong one. It gave it just generic feedback. Okay, so that was the kind of response. So you can see everything anyone typed, right? So this is a multi-part question. It's got more than one answer. So answer D, answer T, answer 1, right? There's more than one part on here. This question has got more feedback and graphs, so you can see what's going on in here. There are more nodes in this tree. It's checking more different properties. So let's say we go back to this question and look at the first question. This is a very simple question, but I know this first question's got random versions. So if I click on this one and we look at the random versions for this question, hidden, this is a stack specific thing, so it's on the stack specific question page. If you go to the basic usage report, oh, sorry, Moodle has a whole bunch of statistics as well. So if we go back to results, statistics and responses, you could get some general Moodle things, but for the stack specific stuff, it's better to come into this basic usage report. And what this does is it groups everything. So 15% of people got the generic feedback, right? One person, probably me, put a weird constant of integration, okay? So, you can see that's overall, and then this is per random version. So you can see everything everybody types. Now, you have to understand what all this stuff means, okay? You have to be able to read the notes the potential response tree does. What I'm trying to do here, and I may not have optimized this, is you're trying to encode every possible stack question in a human, meaningful, compact way, right? So it's very cryptic. It's a bit like the shipping forecast if you're a Radio 4 person, right? It's some kind of cryptic code that will allow somebody that understands it to decipher what's going on. But basically, Scott, yeah, everything's there.
Brilliant. Thank you, Chris. All right. Any other questions? Put your hand up or type it out in the Q&A. No, well, in that case, I'm going to say thank you all for coming. Thank you, Chris, and thank you, George, Robbie, and Constantina. Right, have a great afternoon.
Can I make some just 2 closing remarks? Malthe?
Yes.
Thanks to the people from outside Edinburgh. If you're interested, please keep in contact and email us privately. If you've got institutional difficulties or you want, you're interested in sharing questions and all that kind of stuff, just ask us. We'll help if we can. For the Edinburgh people, if you're working on questions, please, we're not expecting or even wanting you to become experts on stack, right? As you can see, that could take months to do. And it's just probably not the best use of your time. So please contact us and ask for help. Please don't waste an entire afternoon searching through the docs when one of us can just email you and say, it's here in the docs, right? It's absolutely, we want you to be as efficient as possible, and we don't want you to suffer on your own, wading through hours of stuff. Is that okay? There are some of the postgrad interns who have become very good at writing stat questions, and we'll just forward the query to them and they can fix it. What we want you to do is fix typos in questions, improve the work solutions, and do those kinds of jobs. We're trying to just be as efficient as possible. So what you need to do is to work out how to raise problems you can't fix in an efficient way as possible. So in particular, emails that say it's broken are really not, you know, it just could take us hours to figure out what the it is and what broken means. So please, this is the way to show us what it means. So I share my screen again. So if we go into the question testing page, actually that's not the best way to do it. Let's back out of here. So let's edit the question, and I'll come back to this thing here. In the database, every question has a unique integer that identifies it. So up here, it says ID equals. Can you all see that? That will uniquely identify the question. Even if you say the name of the question, it doesn't really tell us which course it's in or which, you know, there are lots of courses, lots of parallel questions going on. And it could be that we've copied the same question in different courses and it's still got the same name, right? So if you really need some help, please copy the ID of the question, and then we will absolutely know, or even better, just copy the whole of that URL, right? Go to the preview page and copy the URL, and then there's absolutely no doubt about what the it is. It's not working, that's the it. And also, when you say it's not working, please tell us exactly how to recreate the problem. I typed in this is what's not working. There is an art to raising a query, okay? So please help us out. And thank you in advance.
Okay, maybe one last thing before we close up is it would be really helpful if ideally right after, or maybe a little bit later, you go back to this Getting Started with Stat course. You scroll all the way to the bottom. I made available this little feedback form. So if you could please fill that out, it gives us a good idea of how the workshop went and what we should change for next time. I'm also going to put a link in the chat. It'd be really, really helpful. Okay, anything else from my colleagues? All right, well, thank you for coming and have a good afternoon.